Hello everyone, welcome to Code Guides, and today we'll see the topic Langchain and its components, and starting with the definition. So it is an powerful open source framework designed to build applications using large language models. As it is an open source, it is free to use and it is designed to build applications like chatbot using LLM. Now it enables training components like LLM, memories, tools, and retrievers into flexible pipelines. We can create a pipeline using all these components like LLM, memory, to store previous conversation, tool, and retrievers, multiple retrievers we can use to build any application. Now, why it's important? So it bridges the LLM with data sources, APIs, and memory. It connects. Langchain is a framework which used to connect LLMs with data sources, APIs, and memory, and it powers apps like chatbot, agents, RAG systems, and also many more applications. So the summary of this slide can be that it is an open source framework, Langchain. It is an open source framework designed to help developers to build applications powered by large language model. Now it allows you to connect an LLM like OpenAI's GPT with tools, memories, and knowledge sources to create context-aware and interactive agents or pipelines. Now the question for you guys is, what if you could talk to your data? Literally. So, what will be the scenario for this question? Moving on to the next topic, real world use cases of Langchain. Now, we can use Langchain for creating AI chatbots with memory, document question and answering systems, custom agent for workflow automation, for RAG, for LLM driven knowledge assistant, and conversational data exploration. So, here in the picture also you can see the use case of the Langchain. We can also use for summarization, chatbot, agents, interacting with APIs, code understanding, querying tabular data, evaluation, extraction, question and answering using documents as contact. So these are the multiple use cases, real world use cases through which we can use Langchain and get our output. Now the question for you guys is, have you interacted with the chatbot that remembers your question? So naturally when we have interacted with ChatGPT also, we see that we go to the previous section or the section which was recorded previously, and we go to see, and it can answer questions based on previous questions were there. So there is a relation. So we can say that it remembers our question and also the previous answer given by it. Moving on, now we'll see the architecture. Now, Langchain apps are built using LLM. We have discussed this. We can use the OpenAI, we can use Hugging Face, we can use Cohere, we can use Mistral. Now, we also need prompt templates for that. We need chains, logic flows. We need memory to store the conversation history. We need tools and agents for interaction, and also data connectors. Like example, we have PDFs and website and database. Here is a picture showing the architecture of Langchain. We have chains, we have LLMs and prompts, we have document loaders and utils, we have agents, and we have memory. That is the vector database. Now here, the each component plays a unique role in managing context, memory, and information access. Next is the working. Here, in the working of Langchain, we can see we have passed on the multiple PDF here, and we have created the chunk using the chunking strategy. As we cannot feed data in one go, so we created chunk of textual data. Multiple chunks are being created. Then we create the embeddings of the chunk, and in this case, we have used the GPT, I guess, for the conversion of text into embedding, and we have stored in vectors, so vectors database. Now, whenever a user asks a question, suppose for example we have what is the neural network, then first of all this question we create the embeddings of that question, then we use the semantic search. It can be question similarity also, and then it searches the relevant document into the vector database. Then we rank the result, whatever the documents are being retrieved, we rank the result according which matches the question embedding, and then we pass it to the LLM, and then we get the answer. LLM plays a role here of creating a answer which is more user friendly and gives more information if it can add. So this is the working of a Langchain architecture. Now the first component of the Langchain is the LLM, that is a large language model. Now Langchain integrates LLMs to generate responses. So it supports OpenAI's GPT, Hugging Face models, Cohere, Anthropic of Cloudy or Cloudy of Anthropic, and more. And its functions are text generation, summarization, question answering. Now we have a reminder here. LLM is the brain and Langchain is the nervous system. So you can see the similarity between the context between the, now here the LLM acts as a brain and the Langchain is the nervous system. So both things are important for a proper functioning of a human body. So that will also be applied to a proper, if a chatbot is considered, we need both LLM and Langchain for the proper functioning of the chatbot. Now moving on, We have the prompt template, that is the second component. Now, what it is basically a predefined text structure used to guide the LLM behavior. So, if a proper prompt is given and proper text structure is passed to the LLM, the hallucination problem can be avoided, and which is the major problem of any LLM. So, predefined text structures are very important when we are trying to build, for example, any chatbot. So, in this case, prompt template should be more precise. Now, why it matters? Ensure consistent responses. Whenever we ask the question, if I'm asking for a chatbot a particular question and it's giving an answer, and I'm asking the same question again, and it is giving a different answer for the same question, and the response are not considered consistent. So at that time, the prompt templates are good. Now it allows parameterized input and it helps reduce hallucination. So we have discussed this problem earlier. Now, why is designing a prompt more than just writing a sentence? This is the question to you guys, and discuss this question amongst you, and so you can get the right answer. Next is the chain. Now, its definition, according to its definition, it is a sequence of calls. Like suppose first will be the prompt, second will be the LLM, third will be the tool to solve a specific task. Now, types of chains are multiple. First one is a simple chain, one LLM plus prompt. Then we have the sequential chain. We have multiple steps. We have prompts, we have LLM, we have multiple retrievers, we have multiple tools, we have agents. The third one is the retrieval chain. We have LLM plus retriever, and fourth one is the custom chain, which is user-defined logic. Now think like a pipeline that connects from tool and responses. So you can think chains as a pipeline that connects different components of a Langchain. So it plays an important role in a Langchain framework. Fourth one is the memory. Now memory in Langchain is equal to short or long term context tracking. How deep you want to track the context. So that would necessarily depend upon our model which we are using. And the types are different. We have the conversation buffer memory, we have the summary memory, we have token window memory, we have the vector store retrieve memory. Multiple other types are also available of memory. We can use it according to our use cases. Now the use cases enable LLMs to remember past messages in chatbot. So if we need a chatbot to remember previous conversation, then memory will play an important role. If I'm asking a user chatbot about any question about the previous record which I had mentioned earlier, then it needs to retrieve or it needs to recall the answers which I had given or all the documents which I had passed with. So at that point of time, memory plays an important role. Now, the question for you guys is, would you prefer a chatbot that remembers you? Of course, everyone will like a chatbot that it knows our previous history and previous conversation. So much more prompting will not be required for again giving the knowledge for the chatbot to give the answer. Now moving on, the fifth component is tools and agent. Now tools are external functions. For suppose for any chatbot we need search engine or calculator or database that LLM can use. So at that point of time we need tools, and agents are LLM powered decisions because that tools to call based on the user query. Now if I assign any chatbot these three tools, search engine, calculator and database, and if I'm asking a question to the chatbot that I need to do a particular calculation, at that point of time, this agent will think about the question, what the user is asking. He's asking about the mathematical calculation. So it will then call the calculator tool among all these three tools, and it will say that calculator will be the best option for answering the user query. So this is the role played by the agent. And example, we can see a bot that decides whether to call Google search, SQL database, or a calculator tool. So the decision of calling that tool is totally dependent on agent, and agent plays an important role for getting the answer more correctly for the user. Now the question for you guys is the agent like a brain that knows when to call which tool? Yeah, we can say, and agent is like a brain. I want you guys to answer this question and discuss it among yourselves also. Now the sixth topic is, or the sixth component of the Langchain framework is document loader and retriever. Now loaders will help to load data from different sources. Now, whenever we pass any document to a chatbot, for example, we need to pass the document. The document can be in format of PDF, PSP, or it can be a web-based document. So, for loading different types of documents, we need loader for that. We have 5 PDF loader for PDF format. We have 5 new PDF also for the PDF format loader. We have CSV loader for the CSV format file. So, multiple, you can think as loader that it brings in document. And then we have also text splitters in line to chunk the multiple documents, as we have seen in the architecture. After feeding the PDF, the much longer PDF cannot be feed it to the LLM in one go. So we need to create the chunk. So for that format, we also need text splitter. And after creating this chunk, we convert them into embedding. And after embedding, we throw them into the vector database. And for retrieving them from the vector database, we need the retriever. And it helps basically to find the most relevant chunk of information using vector similarity. Now, whatever the question is asked by the user, it matches the similarity between the question and the chunk in the retrieve in the vector database, and it is which chunk matches the matches the question, and it retrieves basically that chunk, the most relevant chunk. Now, where it is used in RAG systems to ground answers in real data. So chatbot with which are powered by RAG system are generally to use the document loader and retrieval. Now we have a question for you guys. What kind of documents would you want your bot to read for you? The documents can be of different format, can be PDF, CFP. What do you think? What do you think? What kind of documents you want for your bot to? Now we'll summarize the part which we have learned up till now from the slide presentation. As we have seen, the Langchain is a framework for building apps which are powered by LLM, and the core components of the Langchain are LLM, prompt, chain, memory, tools, agents, and retrievers. Now it helps build smart, dynamic, and context-aware AI system. This is one of the advantage of a Langchain framework. Now these are the question or the class activity for you. So you need to design a chatbot for your college or library of work. And what Langchain components would you need for designing your chatbot? Among all these components, what do you think which are important and which can you use for your chatbot? We have a question here. How does Langchain make LLMs more intelligent and useful? So discuss among these questions and we'll discuss the answer in the next section. Now we'll move towards the implementation part. Now we'll start with the implementation part of the Langchain and its component. First of all, we'll import our OpenAI key. Then we will import OS and try to bring the API key into our environment. Then we will install the libraries and the framework like Langchain. Pip install Langchain, Langchain community. Then OpenAI and ChromaDB, TikToken. ChromaDB is used for we use the Chroma 1 version for the vector database, and token is used to count the number of tokens. So we need to install that. And we also need PyPDF to load the document. So PyPDF will add this output. Now we'll start with the first point of the Langchain component, that is the lower document loader. So from Langchain dot document loader import PyPDF load. Now we are trying to build a small chatbot with RAG. So we need to, and we are feeding the PDF format to the LLM. So we need to convert it into proper, what we can say, the metadata or the format which is good for the or which is accepted by the LLM model. So for that part, we need a PDF loader. From Langchain.document loaders, import PyPDF loader. Now after the document loaders, we need text splitters. So for that, for creating different chunks, if the document format is too large, then we cannot feed the data in one go to the model. So we need to create different chunks. So for that part, we use the text splitter, import recursive character text splitter. We also have character level text splitter. We have multiple types, but for now we'll use the recursive character text splitter. Now after splitting the chunk, we need to convert it into embedding. So for that we'll use OpenAI embedding from Langchain dot embedding dot OpenAI import OpenAI embedding. Now, after embedding, we need to store these embeddings in the database. So, we'll use the Chroma word from Langchain dot vector store import Chroma. Now, after storing the vector, we need OpenAI also. So, from Langchain dot LLMs import open. Yeah. Now we need chains for ritual purposes, and here we are mentioning we are using the use case is our question answering. So for that part, from Langchain dot chain import retrieval QA. Okay. Now in our Google Colab, I've imported this PDF format. Attention is all in the document and this is paper. So we'll try to feed this PDF format to our model, and then we'll try to retrieve the specific answer from this PDF. We'll run this first of all. Okay. Now first of all, we need to load the document. So we are using the PyPDF loader, and we'll mention the path here. Okay, we have mentioned the path. Then you need to load this in doc. So doc is equal to loader dot load. Okay. Now after that, after we load the PDF document, then we need to split. So for that we'll use the splitter, and we have the recursive character text splitter. And here we need to mention the chunk size, how much chunk size you want. So chunk size will give as 1000, and chunk overlap will be 200. Okay. Now we'll store this in chunk. Chunk is equal to splitter dot split document, and here we'll mention the doc file. Okay. Now after creating the chunk, we need to create embeddings and store this embeddings in vector database. So first of all, we'll import the embedding. We'll store the embeddings in open AI embedding. Okay. And then we'll include database Chroma from document, and here we'll mention the chunk which we need to convert into an embedding, and we need to mention the embedding. Okay, now embeddings are stored in database. We need to retrieve this embedding. So for that we need the retrieval QA. From that we need from chain type. Here we'll mention the LLM OpenAI. Okay, we will not mention the model name, and we'll mention the retriever. Uh, Retriever is equal to database, which is active database as retriever. Okay, and we'll run the case. Okay, just a second. Okay, so we had error with the invalid API key. We have solved that error, and we run. Now we'll pass some question QA dot invoke and say what is attention. Okay. It has given the answer. Query is what is attention and result of what. We have got the definition. Attention is a mechanism used in sequence modeling and transduction tasks that allows for modeling. So yeah, it's working. So we have tried to create a small chatbot here using different components of the Langchain. We have used the document loader, that is the PyPDF. For creating different chunks, we have the recursive character text filter. For embedding, we have the OpenAI embedding. For storing the embeddings into a vector database, we have used Chroma, and for retrieving the document from the vector database, we have used the retrieval QA. As we are using the question answering, we have mentioned the LLM, and we need to mention the retriever from the which we are accessing the retrieved document, that is the database DB as a retriever, and we have created a small chatbot which is now answering the basic questions which we are asking, and it is returning this document from the PDF which we have used here. That is the attention is all you need. So yeah, so this was the short implementation part of the Langchain component. Hope you guys understood, and if you have understood, please like this video and subscribe our channel, and we'll meet in next video. Thank you and bye.